Hey students, welcome back to lecture series on Z transform. For similar videos, go and check in my I button. You will get my complete lecture series on I button, or you can check in description box downside. You will get my complete lecture series based on the linear differential equation with the constant coefficient and Fourier transform, Fourier sine transform, cosine transform, and Z transform. In my today's video, I'm gonna explain to you all guys one of the important property from Z transform. Okay, so whenever we have Z transform sine of alpha k, okay, mostly we have 3 to 4 most important properties, guys, like sine alpha k, like cos alpha k. Okay, there are hyperbolic function, okay, sine hyperbolic alpha k, cos hyperbolic alpha k. Okay, so these 3 to 4 properties are most important here, guys. Okay, so if you are going to solve directly the Z transform, it's nothing matter, you will get the answer, but it's a time taking, guys. Okay, so this time taking process, just to avoid this one in your exam, you can apply directly these standard properties. Okay, so I already explained 3-4 properties in my last lecture, so I'm gonna explain to you all. This sine Z transform of sine alpha k can be written as k greater equal to 0 z sine alpha upon z square minus 2z cos alpha. Okay, this one is a cos alpha plus 1 and mod z greater than 1 over here. Okay, yes, so let's get to prove this property. First of all, I'm gonna consider this side. I'm gonna consider this side. I'm going to apply Fourier Z transform. Oh, sorry, we are going to apply Z transform over here, and then we're gonna prove this side over here. Okay, which is z sine alpha upon z square minus 2z cos alpha plus 1. Okay, yes, so as we know that we already learned one standard result. Okay, one standard result that I'm going to apply over here. Okay, yes, so what is the standard result? Sine x, it can be written as e raised to ix minus e raised to minus ix. Okay, e raised to ix minus e raised to minus ix divided by 2 times I. This one is a very much important property result, guys, that one used everywhere in our Z transform. Okay, as we have Z transform, Fourier sine transform, cosine transform, you have to deal the value for sine and cos. Okay, so this one is the value for sine. So if you want the cos x, okay, so we can write cos x as e raised to ix plus e raised to minus ix divided by 2 only. Okay, as these are the complex term. Okay, so we write sin x and cos x in this form. Okay, so using sin x, I'm going to prove this property. Okay, as we have sin alpha included here. Okay, so let's consider this side. Okay, I'm going to consider Fourier transform of Z transform of sin alpha k, Z transform of sin alpha k when alpha k greater than 0. Okay, when k greater than 0. So I'm going to write this one as now see that Z transform keep as it is, just replace the value for sin alpha k. Okay, it is a sin x, so I want the sin alpha k, so replace x as alpha k wherever you found x. Okay, wherever you found x, replace alpha k. So I'm going to write this one as sin I alpha k minus e raised to minus I alpha k divided by 2i. Okay, yes, e raised to I times alpha k. So ix replaced by alpha k. Okay, e raised to I alpha k minus e raised to minus I alpha k. Okay, divided by 2i. Okay, this one is the bracket complete. Okay, I hope you all have understood how I have written. Now see that whatever the constant term inside here Z transform, now take it outside, because this doesn't matter when it is the multiplication. When it is the multiplication, constant term doesn't matter in our Z transform. So as we can see, 2 times iota, we know that the square root of minus 1 it is there. Okay, so 2 times iota, it is a completely constant term here in our entire Z transform. Okay, and it is a multiplicand to this step. Okay, so I'm going to take 1 upon 2 times iota out of the Z transform. Okay, 1 upon 2 times iota, I taken it is a outside here. Under bracket, I'm going to write here Z transform of e raised to I times alpha k minus e raised to minus I times alpha k. curly braces complete, bracket complete. Okay, this one is our required Z transform here. Okay, now see that I'm going to expand by linearity property. I'm going to expand this Z transform over here. Okay, so Z transform A minus Z transform B, if it is there now, we can write Z transform A minus Z transform of B. Okay, yeah, this one is the way to write the Z transform. Yes, so let me write 1 upon 2 times iota, 1 upon 2 times iota under bracket Z transform of e raised to I times alpha k curly braces complete minus Z transform of curly braces e raised to minus I times alpha k. Okay, bracket complete. This one is our expanded term of form of a Z transform. Okay, this is the Z transform. I just applied Z transform here separately and here separately. Okay, it applicable for positive negative sign also, guys. Okay, yes. Now see that this one is some standard form Z e raised to I alpha k. Okay, so we are going to apply some standard form for finding the Z transform over this term. And in our last property, we learned Z transform of a raised to k. Okay, so I'm going to apply Z transform of a raised to k here. Okay, what is the Z transform of a raised to k when k greater than 0? As we have k greater than 0 only. Okay, so I'm going to apply the condition for k greater than 0. Okay, so we are going to write this Z transform upon Z minus a. Okay, this one is the given required Fourier transform, sorry, Z transform that we learned in our previous part. Okay, Z transform of a raised to k when k greater than 0 can be written as Z upon Z minus a. Okay, yes. Now e raised to I alpha k, I'm going to compare with this one. Okay, e raised to I alpha k and e raised to minus I alpha k. Okay, these are the two terms now. We have to apply Z transform over here. Yes, we have to apply over here. So compare this term with a raised to k. Okay, so a raised to k, let me see that what is the value for a. It is e to the power I alpha. This is the value for a, and k it is as it is. Okay, again a raised to k, you can see that what is the value for a. It is e raised to minus I alpha. Okay, see that I'm going to explain it again if you are confused. Okay, so I want the Z transform of this term as well as this term. So I written these two terms down here, e raised to I alpha k, e raised to minus I alpha k. So instead of e, I written a. What is the a here? A, it is a constant. What is the e here? E, it is also constant. What is the value for e? Which is a 2.78 something dash dash. It is the value for e now. So e, it is also constant here. Okay, so e is constant, a is constant. So I consider entire time I times alpha is also constant. Okay, yes. So what I have done, I consider a as a e raised to I alpha, k as it is there, a as a e raised to minus I alpha, and k as it is there. Okay, so on all the terms are k and greater than 0. Okay, so I'm going to write Z upon Z minus a. Okay, so what is the value for a? First term, for this term, value for a is a e raised to I alpha. Okay, now see that for a which is equal to e raised to I alpha for this term, and for this term a which is equal to e raised to minus I alpha. Okay, compare this one with the a. Okay, now this compare both of this with this form. Okay, so we write Z upon Z minus a for this, Z upon Z minus a, and for this Z upon Z minus a. Okay, so I'm going to write in my next step 1 upon 2i, keep it outside, under bracket Z upon Z minus a. So for this first term, what is the value for a? E raised to I alpha, e raised to I alpha. Okay, Z minus, okay, Z minus a. Okay, so after that minus sign, it is between them. Okay, Z e raised to minus I alpha k. For that a, what is the a here? Minus e raised to minus alpha, and for this Z transform Z upon Z minus a. Okay, Z upon Z minus, what is the value for a? We need the value for a, e raised to minus I alpha, e raised to minus I alpha here, e raised to minus I times alpha. Okay, so remember that we have to we consider this one and we have to prove this step here. Okay, so take Z common from out this bracket, Z upon 2i under bracket. So we left here 1 upon Z minus e raised to I alpha minus 1 upon Z minus e raised to minus I alpha, bracket complete. Okay, see that I written this step here next. So guys, here see that we are going to multiply this cross multiplication here. Okay, so Z upon 2i keep as it is. I'm keeping this term as it is over here. Okay, this multiplied by this multiplied by this multiplied by this denominator. Okay, yes, Z minus e raised to minus I alpha this into this one, okay, minus of this into this, okay. So minus z plus, okay, e raised to I alpha. Okay, now see that what I have done. So this multiplied by this, I written here z e raised to minus I alpha. So again minus sign multiplied to this bracket z minus, so minus z plus e raised to I alpha. Okay, so a total divided by, we multiply these two denominators. Okay, yes, so z minus e raised to I alpha multiplied by z minus e raised to minus I alpha. Okay, I written this one. So as we have numerator, try to cancel the possible term from the numerator here. Okay, yes, so what is the possible term we can cancel from the numerator? So see here guys, that plus z minus z I can cancel here. So we can see that we have one standard form in our numerator, e raised to I alpha minus e raised to minus I alpha. Multiply to I, divide to I, we will get the term of sin alpha. Now see that we have here sin alpha. We are trying to create the numerator as a sin alpha. Okay. So next part I'm going to write it here guys. See that. So what I will do, e raised to I alpha minus e raised to I alpha. I'm going to solve the numerator only. Okay. E raised to I alpha minus e raised to minus I alpha. So see that plus e raised to I alpha I taken it here. Okay, minus times e raised to minus I alpha taken it here. Okay, this one is only numerator, so I can multiply this term to the 2i and denominator 2i. Okay, so I multiplied 2i, divide 2i to the numerator. Okay, I'm solving only the numerator. So this one we know that this one is the value for sin I alpha. Okay, so what is the value for sin alpha? Sorry, it is the value for sin alpha. So sin alpha can be written as, okay, sin alpha can be written as e raised to I alpha minus e raised to minus I alpha by 2i. Okay, so we write 2i into sin alpha. We write this term as a 2i into sin alpha. So we have numerator 2i into sin alpha. Okay. Now denominator I'm going to solve. This one is the part of numerator. So that 2i can be cancelled here with the 2i, but I will cancel it later on. I don't want to make you all confused. I want the multiplication of these two brackets. Okay. So how can we multiply these two brackets? Multiply first term to first term to second term to first, second term to second. So z into z, we write a z square. Okay, z into z square minus, as it is here, z into e raised to minus I alpha, z into e raised to minus I alpha. Okay, z into e raised to minus I alpha. Okay, again multiply this one minus, okay, z into e raised to I alpha, z into e raised to I alpha. Okay, z into e raised to I alpha. After that multiply minus e raised to I alpha and minus e raised to minus I alpha. Okay, so minus it goes to the plus, e raised to I alpha into e raised to minus I alpha. So when we have base same way, they add their power. So I alpha minus I alpha, we write the power 0. So e to the power 0, it gives us the value 1. Okay, this one is the multiplication of a two bracket I written here. Okay, yes, it is way easier guys, don't need to explain more. Yes, so what we do now, try to see that can we take any term, create term here, as we have denominator 2z cos alpha. Try to create the term of a cos alpha over here. Okay, so for cos alpha we need a 2 here numerator, denominator 2. So multiply 2 to the numerator, 2 to the denominator. So I'm going to write next step as a z square minus, take z common from both term, multiply to e raised to minus I alpha minus e raised to I alpha by 2. Okay, e raised to minus I alpha minus e raised to I alpha by 2. Now see that this minus z e raised to I alpha, okay, and minus it is minus z e raised to I alpha. So we have the term here z e raised to I alpha. So what I'm going to do, I'm going to take negative sign also here outside, so both become positive. Okay, that negative I taken outside, z also taken outside, multiply 2, divide 2 here. Okay, bracket complete, plus 1. I hope you all have understood how I have written. Okay, so what I have done, I'm sorting this step here. Okay, and at the end I'm going to put it here. Okay, so I'm solving this step here, numerator I solved here, denominator I'm solving here. Okay, so multiplication of these two terms I written over here. So I'm trying to create at the middle part as a cos alpha. Okay, so z square as it is here, so minus z I taken from both term outside here, 2 multiply, 2 divide, and 2 also taken outside. So e raised to minus I alpha plus e raised to I alpha by 2 plus 1. So we know that cos alpha can be written as e raised to I alpha plus e raised to minus I alpha by 2. Okay, So let me write the cos alpha. Here I'm writing in my empty space. Cos alpha can be written as e raised to I alpha plus e raised to minus I alpha by 2. Okay, this one is our cos alpha. Okay, so I'm going to apply this cos alpha over here. Okay, yes. So z square minus 2 times z cos alpha plus 1. Okay, this one is the expansion for our denominator. I'm going to replace this value over here. Now see that z upon 2i under bracket numerator I solve 2i cosine alpha, 2 times I sine alpha over here, denominator I solved z square minus 2z cos alpha plus 1. Okay, z square okay, minus 2 times z cos alpha plus 1. Okay, bracket complete. Now see that 2i can be cancelled. So we left here z sin alpha upon z square minus 2z cos alpha plus 1. Okay, this one is actually the proof of our given identity. Okay, z sin alpha can be, when greater or equal 0, can be written as z sin alpha upon z square minus 2z cos alpha plus 1 mod z greater than 1. Okay, so this one is our required proof. We found it here. Okay, yes, I hope you all have understood, guys. For your reference, you can note it down this result. So in our next example, I'm going to apply example to the directly this form. Okay, yes, it is way easier to solve. For your reference, you can note it down these notes. See that I written all over here, guys. Yes, everything I written here. Okay, yes, that is the entire proof of our statement. Okay, let me continue one of the example that can be helpful to understand the concept for us. Okay.